best cars so far that we've seen today. Right now, Kettering in the 28th spot overall. Navy Valley moves into 20th spot overall.
The Formula SAE enterprise here at Michigan Tech develops students' skills by helping them apply their classroom skills to a real-life setting, preparing them for work in the auto industry. We have 5 different sub-teams on Formula. There's powertrain, chassis, composites, electrical and controls, and business. Engineers on the team get experience with design, fabrication, manufacturing, testing. They really get the experience that helps them stand out in the industry. We're welcome to all majors, but we are mostly recruiting mechanical engineers, electrical engineers, business majors, STCs, and more. But yeah, there's multiple different areas that a student can develop their skills. There's design, there's fabrication, there's manufacturing, testing. On the business and STC side, there's a lot of media and promotional skills that you can build. And on the business side, you can expand skills in project management, finance, marketing. So there's a lot of room for students here at Michigan Tech to get a really awesome experience at FSA to prepare them for the real world.
A big thing that the Formula team has helped me with is really analyzing results and then making engineering decisions based on those results. Before the Formula team, I had worked with vehicles in the past, but it was a lot of just troubleshooting, just winging things. The Formula team has definitely gotten me the engineering fundamentals that will be needed in future employments and future in my career goals.
Formula competition is the most fun we all have throughout the entire year in Formula. All of our work that we put in for the past few years really come to life, and watching the car compete and watching our teammates drive the car that we worked so hard on is just really rewarding.
Competition is kind of the ultimate test of everything you've worked on throughout the entire year. You design parts from start to finish, and the main goal is to score more points at competition, whether it be in the business events or the dynamic events where the vehicle's driving, or even the static events. So like we do a tilt test to make sure no fluids leak out of the car, things like that. I think that Formula takes teaming experiences to the next level. As far as teaming in individual courses on campus that you may experience, it's one semester with 2 or 3 other people, and this is a whole different ballgame. We have 50 people on our Formula team, and you talk to almost everybody.
Formula has really opened a lot of doors for me as a budding engineer. I have received many offers of internships pretty much solely based off of being involved with a Formula team. I have gotten a lot of experience that I wouldn't have gotten on any other team, some like real world, real time experience, and it's really helped me understand what it's going to be like as an engineer in the field later on.
The chassis sub-team as a whole designs, approves, and makes sure that the entire car can be fabricated and then proceeds with fabrication. So basically anything that's welded, any metal work, any of that is done by the fabrication, including suspension. Basically any of the tubing, it needs to be cut to length, notched, positioned properly in the car, and then welded on. A lot of times that includes the welding table with the jigs to ensure that we have accurate geometry in the frame so that it's accurate to the design.
So originally we made all the tubes in-house for the tube frame. So we went into the model, found the angles, notched the tubes to the angle in the model. Since we're doing that by hand, that's not 100% precise. Recently we've looked into actually having the tubes laser notched from the model by separate companies, and we found that that's a way better way to do it because it's going to be way more accurate. The car is going to go together the way it was designed to go, and it's definitely a lot faster of a project because it takes like maybe a week to 2 weeks for them to actually laser notch the tubes.
The reason that we need this money is because as engineers we're not as good at fabricating as we are at actually designing good race car chassis. So in order to free up some time for us to be able to continue on our 3-year build cycle, it is extremely beneficial for us to be able to send out our chassis tubes to be notched with a laser machine to precision tolerances instead of having us build them in-house. This is an expensive process, but it really saves us time and allows us to design a better race car chassis.
So the scope of the project is to continue our 3-year build cycle where we constantly have a car running, we have a car that's being put together, and then we have a car that's being designed. So we have to bring a new car to competition every year. So that means a new completely designed chassis every year, which means you got to put all the tubes together, make sure that's squared away. So the scope of the project is to be able to laser notch tubes and get them sent out so that we don't have to spend all the time actually cutting them ourselves, because that's really time consuming for full-time students that are also still trying to build a Formula car on the side.
Some of those obstacles, like I mentioned before, were just not having the fabricating skills to actually notch every single tube to the exact tolerances that we need it. It really helps us when we can get a bundle of tubes back to us that are cut perfectly as we modeled them and designed them, and then just put them together and weld them.
On the chassis team, my current project is preparing the model and the supporting documents to be sent to the company that will be notching and laser cutting our chassis frame tubes for. So essentially I've been working on updating a 3D model and getting it completely ready so that they can efficiently laser cut and notch our tubes.
So laser notching, basically that just adds a whole nother level of precision. Right now, the team being at a manageable size doesn't have the manpower to accurately notch tubes, especially with people leaving and coming into the team so often. That's a process that's more learned over time. Notching accurately will basically speed up welding time, speed up fabrication time in general, and it'll eliminate the process of using a non-accurate tube to make the car.
Instead of having to notch them all the time in the shop consecutively throughout the year, we want to be able to have all of the tubes in a CAD model where they need to be notched, what length they're at, and send them out to a company and have them laser notch them, send them back to us, and the only thing we have to do is weld. Where we would just get the tubes, we'd have the welders on the team just completely weld chassis together and take maybe a week, and then we'd have a complete car.
Building the car the way it was supposed to be designed to allows for all the components of the actual car to fit onto it, because if there's like small errors in the frame when we build it, then some components might not fit the way we wanted them to, which will affect the drivability of the car depending on the component, and it might shift the center of gravity of the car, which will definitely affect drivability.
Our current method was less than ideal. We would use a hole saw with an angle indicating device to notch each tube at angles that we thought were where they needed to be. This resulted in a lot of wasted material and a lot of time commitment to do that sort of thing. The Cummins funding would be spent on sending our entire chassis out to get laser notched to the precision tolerances that we desire. This would free up a lot of time for us to better design chassis and allow us to keep our 3-year build cycle going. So we go to school at Michigan Tech and we're buried in snow for half the year. As a formula race team, it's not ideal for us. We only get a little bit of testing in the fall and a little bit of testing in the spring before we go to competition. So we've come up with a 3-year build cycle where in 1 year we're actually designing a car to go to competition 2 years out. We're actually building a car to go to competition next year, and we're actually testing a vehicle that is going to competition in that current year. That allows us to overcome the climate that we face up here, and if we got this funding, it would allow us to continue on that 3-year build cycle and stay ahead of it, whereas in previous years we've fallen behind.
Being full-time students, it's really hard to find the time to design new parts for the car, but also be putting the next car together so we have something to run the next time we go to competition. Being able to send these tubes out would save us so much time to be able to actually go back on the car and say, okay, now we can look at this part of the car and design something better about it instead of using the same design over and over and over again because we don't have time to look at it.